Well, welcome to lesson 29 of this Arduino C++ course, and today I'm continuing with serial communication. This is part 5, the final part of this series, and today we're going to be looking at how to connect the RS485 module and what that means for our Arduino network and communication systems. Now, in the previous lessons, we've learnt to connect Arduino UNO to UNO, UNOs to Megas. We can even connect UNOs to ESP32s via different methods. But in all of these systems, it has always been just the two boards speaking to each other through the TX and the RX pin, or with the Arduino UNO, those are using software serial versions of the TX and RX. Now, much as connecting two boards together is useful, there are times when you need to connect more than two Arduinos together. And this is a RS485 network. This is an RS485 module. And each of these boards is connected to one of these modules, and that is allowing the different boards to talk to each other. So you'll see I've got one master board, and then I've got slave A, B, C, and D. Now, just to give you an idea what is going on here, the master board happens to be speaking to board B, which is flashing this LED on and off. At the same time, slave A is talking to slave C, and that is flashing the red LED on and off at a different interval. Slave B, which is driving this blue LED, is also controlling the blue LED on slave C. And finally, slave D, I just have a button down here, and when I press the button, the green comes on, and when I release it, the green goes off. Now, the reason for building this is just to show that not only have I got communication between the master and the slave, and obviously I can have communication from the slave to the master, but we also have communication between the different slaves. So each board can talk to all the others. So let's have a look at how this is done. So as always, if you click on the link below the video, that will take you to the lessons screen. And as always, that gives the resources for today's lesson. Now, I've got a circuit diagram. I've also got the pinout of the RS485. So let's get started. So going back to the circuit diagram from lesson 26, we can see that we connect the TX of one board to the RX of the other, and again the TX to the RX going backwards, and we have the ground connection. Now, the problem is if you want to add a third board, you can do it in that this TX could go to an RX pin on another board, but the TX from that other board can't come back to the original UNO because it's already connected to the RX from an alternate board, and the code basically will not work. I've done some experiments just to test it, and it does not work. So realistically, with this system, we can either send out to numerous boards, or we can send and receive between two boards, but that's all we can do with conventional serial communication. Now, the issue isn't actually our communication protocol, because the communication protocol we will use today is very much based on the last lesson, but our issue is based on the fact that you can't have those TXs and RXs connecting to multiple boards. So what happens here is we connect our TX and our RX to the RS485 module, and we also have another connection, which is the trigger pin. And if you notice, when this then comes out of the RS485, I've got a white wire and a yellow wire. Now, this is what I would call there's an A wire and a B wire, as you'll see, and the communication, the signals that are sent through, are the difference in voltage between the two wires. Now that's a little bit of a weird one to get your head around. It's the difference in the voltage between the wires, which is not necessarily the difference between ground and the voltage going through the wires. The reason that's important for us is it means that you do not have to have a ground connection between all the different Arduinos. All we need is our two wires. So there is no need for a ground connection between all the boards. And that becomes really useful because just imagine that this particular board here is at the end of my garden and it's being powered by a solar unit of some kind. I then don't have to worry about running the ground wire back into the house to connect to my other Arduino. All I need to do is have my two wires that my communication is going down. So looking at a close-up of the module, we have one pin that is connected to the Arduino RX pin, or whatever pin you're using if you're using software Serial. We have the Arduino TX pin. I then have a 5 volts that is going to the VCC. Obviously ground, this is the ground of the Arduino. And then I have a B and an A. And these are these two wires. I've got one white wire in my diagram and a yellow wire also for the opposite. And these are the ones that are dealing with the signal. Now, I am just using these pins on the end, but these two pins here are duplicated with these screw terminals because obviously I'm just working on a breadboard. But these modules are capable of sending a signal a very, very long distance. RS485 will communicate up to 1,200 meters. That's 4,000 feet for those of you using the old system. That is a very long way. I haven't been able to test it because one, my garden isn't long enough, and two, I don't think I can afford 1.2 kilometers of cable. But that is the basic connection. Now there is one other bit here. This is the transmit pin. Now you connect these two pins together and these go to the transmit on your Arduino. Now the transmit pin is a bit like the button on an old-fashioned walkie-talkie. If you had an old-fashioned walkie-talkie, if you release the button, it will receive communication. If you press the button, that is when you speak. Now that's exactly what's going to happen with this module. So whenever we want to send something, we send the transmit pins high, but as soon as we've finished transmitting, we set the pin low so that we can then receive any communications on the bus wires. So going back to the circuit diagram, that now means that if this Arduino presses its transmit pin, it can send information onto the bus, and all of these other Arduinos will pick up that information. And then of course, once that pin has gone low, someone else can transmit. Now there is one scenario that cannot be allowed to happen, and that is we cannot have multiple transmissions running at the same time, because we've got a two-wire system here. So if this Arduino starts sending out a load of signals and this Arduino starts sending out a load of signals, they are either going to cancel each other out or completely confuse each other. So part of the system that we have to build today is a protocol that makes sure that only one board speaks at any one time. And that's what we learned realistically in the last lesson, lesson 28, when we looked at the master and slave system. Now, as always, all the code is available for download off the Digital Town website. So let's get started with our first sketches. Now, going back to the desktop for the first sketches, all I'm going to do is my first tests between the master and slave A. So we're going to start off with the master sketch, RS485 master version 1. Now I have put a list of the pins that I'm using. So I've got my TX is on pin 11, RX on pin 10, because I'm using software serial. Obviously, if you want to reuse this for the Arduino Mega or something like that, then you would comment out these lines and obviously connect to serial 1 TX and serial 1 RX on your Mega. Now I have another connection. That was the two orange wires that came off those two center pins. Those are my transmit wires, and those are going to be connected to pin 9. I've then got a timer. I'm just going to send out a signal every 1 second, and the information we're going to send out is just a single test byte. Now this sketch is going to be a very simple sketch. All I'm trying to do is send out an ever-changing value, which is the value of test byte, and this is just so that I can check that the slaves are picking up the information correctly. Otherwise, if your wiring is wrong at this point, then you're going to be stuck for the rest of the session. Now, I'm going to be honest with you, this sketch saved my life because I did have a wrong wire. I'd got a white and a yellow connected incorrectly on one of the RS485 modules. So yeah, one of my slaves wasn't working, and obviously I could figure it out because it wasn't receiving. Now, we have serial monitor running so that we can see the value I'm sending, serial 1 beginning, which in my case is software serial. I've then set the pin mode for the transmit to an output, and I've just put a little delay in and then written it low. To be honest, these two lines aren't really needed because the pin is low by default, but a bit of a belt and braces just in case. Now we come down to the main loop, and as you can see, it's not much of a main loop. So we've got current millis running our timer, again, non-blocking code. We've got the timer code, and again, if you don't understand this type of timer, if you look on the resource page, I think it's from lesson 3 or something, you can learn about how these timers work. I am then going to serial print to the serial monitor the byte value that I'm going to transmit. Then the way this works, I digital write the transmit pin high. So we're pressing the walkie-talkie button and saying, okay, we're going to start sending information. I then serial 1 write that test byte. So that's exactly the same as in previous sketches. We're doing the serial 1 write. It's just that we've had to press the transmit button first. And then there is a new function that you will see here, serial1.flush. Now this is a bit of a weird function, and what it does is it puts in a sort of a mini delay until the write buffer has been emptied. Now at the moment I'm just putting in a single byte of information, and we know that from the previous lesson that at a baud rate of 9600 that a single byte to transmit takes just over 1 millisecond, 1.04 milliseconds to be exact with the system that we're using. Now if I wrote that serial write, let's imagine now that I am sending 10 bytes. So now we're going to be taking just over 10 milliseconds. Now to us, that's nothing. But if I took out the serial flush, I would put 10 bytes into the buffer. I would then send the transmit pin low, and that would cut off any transmission. And that would probably mean that probably the last 8 bytes of my 10 bytes would never get through, because I'd ended the transmission before, if you like, I've let go of the walkie-talkie button halfway through the conversation, so the second half of the conversation never gets transmitted. Now what serial flush does is it causes a delay to your code that waits until the transmit buffer is empty. So if we put 10 bytes in, then it's going to wait. The delay is going to be probably about 9 milliseconds because it will have taken us nearly 1 millisecond to put the information in, maybe a little bit less. But basically this allows an exact delay to the point that all your data has been transmitted. And then it says, okay, conversation over. And immediately then we put the transmit pin low. And then all we do is increment the value of test byte. And you can see that on my serial monitor, this value is slowly increasing. Now, just because I think I'm transmitting, it doesn't mean that I know for sure that I'm transmitting. Is anyone receiving? So let's have a look at the slave sketch. This is RS485 slave version 1, and this is a very, very simple sketch. So looking down the sketch, I have put the transmit pin in, but we don't use it. It's just there because, let's be honest, I copy and pasted from the other sketch, and all that it's doing is checking if there has been a byte received on serial 1, because we don't need to press the transmit to receive. So as the transmit has been set low, all I'm doing then is checking if there's anything available, and if there is, I'm going to serial print out the value. And here we have the values coming through. So on the left we have the transmission, on the right we have the value that is being received. So once this has been completed for one board, what you then need to do, unfortunately, is load this slave sketch onto all the other boards. Now, there can be an issue having the same sketch opened for more than one board. So the way you get round it is open a new sketch, and make sure that I'm connected to the same COM port, open the serial monitor, and we can now see that value coming down. Then all I do is look for a COM port of another board. We're now going to go to COM port 11, upload the sketch to COM port 11. There we go. And we can now see, if I pull this up so you can see all the values coming through, you can see that I've got the same value being transmitted and received on all three boards. And you then repeat this for all the different boards to make sure that each one of them can receive. Now, one of the fascinating things about the RS485 protocol is that not only will it transmit over a distance of this sort of 1,200 meters, but you can also have up to 32 boards connected. And under certain circumstances, you can even get more than that connected. Now, obviously, I don't own 32 boards or 32 RS485 modules, but it gives you an idea that you could build quite a substantial network if you needed to. So if you had to have a lot of boards with a lot of different sensors in different places, this is a protocol that you could use safely. Now, once we know that everything is communicating correctly, let's get on with some real programming. Now, to save time, I'm going to recycle the code from serial version 14A master. Now, this was a sketch that was sending out and receiving data. So if you don't know how this sketch works, it'll be worth watching lesson 28 to find out, because I'm not going to explain everything again. Right, as before, software serial, and as in the previous lesson, our packet is going to consist of a start byte, then there will be an address byte, a data byte, a checksum, and then the packet end. So the packet start and the packet end values are fixed. I've also got my array for the received data, because obviously we're going to send and receive. I've got a ping address in here and I've set it to 0. Now the reason is that actually this board doesn't get pinged, but it just helps to keep a consistency within the code. So this board 0 isn't pinged because the master is in control of the timing. Now, when I talk about the master being in control of the timing, as I said, you cannot have two boards with a transmit pin pressed at the same time. So if we imagine this board bottom left is the master, this board is going to send out a ping with a board address. So the first ping will be to board 1. All of these boards will receive that ping, and as soon as it's sent the ping, it shuts off its transmit pin. This board will then receive that and go, oh, that's a ping for board 1. If it's got some data to send, it will immediately send its transmit pin high, transmit the data. Now, don't forget that data doesn't just go to the master, it can go to any of the boards. And as soon as it sends that data, it then shuts down its transmit pin. And then at a timed interval, the master then pings again, pings board 2, board 3, board 4, board 5, and if we wanted to, right up to board 31. And it means that each of these boards has if a ping that's sent to it, and when that ping is sent, if it has information to send back, it can send it, just as we saw in the previous lesson. So just as in that original sketch in the last lesson, which was serial version 14A master, we've got our timers. I'm leaving the ping timer at 30 milliseconds. I've done some tests on some of this and I had it running at about 16 or 17 milliseconds, but I'll leave it at 30 for now. We've then got the beginning of the sketch. I'm making sure that the transmit is low at the beginning. This bit of code here is just to reinforce the fact that that pin must be low before we start. And then I'm going to start my timer. Now I am going to send out this information. My ping is going to be sent every 30 milliseconds. And this is the packet that I am going to send out. So I'm going to send a value of 0. Now in the system that we've built, we're saying that if the address byte is 0, then it is a ping. And then I'm going to send the ping address. I'm also going to reset the incoming byte position just as before, so that when information comes back, it starts at position 0. I'm going to increment the ping address, and if that address gets to a value greater than 4, it's going to set it back to 1. Notice it doesn't set it to 0. There's no point pinging myself. At the same time, in the main loop, we've still got that function that looks for a received packet. Now, the received packet code has not changed at all. That's exactly the same as in the last set of sketches. And once again, it's going to be looking for the checksum to make sure the checksum is correct. It's also going to be looking for a valid packet end, and it's also checking up here for a valid packet start. So it's made sure that the packet of data being sent over, the 5 bytes it's received are in the right order, and all seem to have been received correctly before it deals with them. Then I've got my process packet code, and in the last one we were sort of sending some LEDs high and low. All I'm going to do for this sketch is just serial print out the address and the data that has been received. But the piece that we really need to look at is when we send our data. Let's scroll back up to that. So this is that function that we have, TX packet. Now, if we go back down to that function, TX packet, we have a send array that contains the 5 bytes. Just as in the previous sketch, nothing's changed. And again, packet start, address, data, checksum, packet end. Send array, element 0 is the packet start. So we've put our value in, that'll be the 255. We've got our packet end, that's going into element 4, that's going to be a value of 254. We've then got the address and the data, and then what I have done is I have an integer here, checksum, which is the value of the address byte plus the data byte, and then we're sending the low byte of that as the checksum value. Again, nothing's changed there. Right, now we come to the bit where things have changed, and the change is totally minor. Once again, just before I send the Serial.write, so in the previous versions of the sketches without the RS485, we would just send out the 5 bytes of data. The only difference now is I have to press my transmit pin, send that pin high. I then send my 5 bytes of data. I then go serial flush, make sure that all the data has gone. As soon as the data's gone, send the pin low, and that's the end of it. Now you'll notice then I'm going to serial print out the values that I transmitted, but that is done after all of this has finished. If I'd tried to do this after I'd serial printed out, I would start to interfere. There would be data probably starting to try and come back while I still had my transmit pin high. So as soon as the data has finished, it's very important to wait for that flush and then immediately send your transmit pin low to say, I've now finished my communication. The bus is now available for a response. So now I've uploaded the code, and as you can see, I've got loads of information going out. So what I'm going to do is just change the send time. Scrolling up, he says, and we're going to set that timer back to 1000 instead of 30. Upload it. And now we see the value changing once a second. Now what I'm now going to do is bring in that slave sketch. And if we open it up, you can now see that as the information is coming across, let's just stop the scrolling. We can see that packet start, first byte is 0, so this is a ping. I'm pinging board 1. The checksum of 1 and 0 is 1. That's the packet end. Then we've got packet start. It's a ping. This time we're going for board 2. Checksum is 2. End. And so on. And as we work down, we can see that we then get to board 4. And then immediately we start pinging from board 1 again. So we can see, and these are quite useful, this little slave sketch. It's quite useful at times just to be able to see the data that is actually being transmitted on the bus, because this will pick up absolutely everything. Now, as a response to that master's ping, we're now going to reuse the code from Serial v14b slave. And again, not much of a change has been made. The first thing, obviously, we have our ping address. This is going to be board 1. This for me is slave A, and I've got my transmit pin in there. This is going to respond with a ping every 1.4 seconds. I just picked that sort of random interval of time just because it meant that it didn't respond to every ping, so that I could see something where there was data to be sent and when there wasn't data to be sent. Now you'll notice I've commented out this bit here because it really wasn't needed, but it was just a reinforcer to say that pin must be low when we start. Now the first thing we do is we receive the packet, and once again the RX packet, the code is the same basically as the previous sketch. He says looking desperately for where it is. There we go. So this is a function that checks if there is anything available on serial 1, and if it is, it puts it in a byte. It does its check once again to see if it is the packet start. If it is, we move on, and then we do take our data and our address, do our checksum, and once again we work out if it's an invalid packet checksum or if it has an invalid packet end. If it doesn't and everything is good, we go to this function process packet, and process packet, all it does is it serial prints out the information we've received. Again, in a bit of production code you really don't want the serial print in there, but it really does help during testing to see. And then in the previous sketch we had this bit where we can take the case, so if the address is a value other than 0, we may want to do something with it. We were turning LEDs on and off in the previous sketches, but in this one, if it's a 0 and the data is equal to the ping address, which is our board address, then we're going to check that FIFO buffer, and if we've got some information to send, we're going to transmit the packet. Now, once again, with the transmit the packet, the only change is we send that pin high, we wait for the flush, we send the pin low. Now, going back to the main loop, for the response, I've got a timer running, and again, it's running every 1.4 seconds. And all it's going to do is it's going to put a random value between 1 and 100 for the address, and a random value between 101 and 255 for the data. Now, it may seem that I've gone through this sketch quite quickly, but realistically, apart from the values that I'm transmitting, the only real changes in this sketch from the last lesson slave is this bit down here where we have the transmit pin, the serial 1 flush, and then sending the transmit pin low. So let's get this uploaded. So that's all uploaded, and as you can see, everyone is communicating happily. Let's just stop the scrolling. So we can see here I have pinged board 1, and this is saying I've received this ping and I've got some data to send, so I'm going to send it back. Now, hopefully, if we can find one, there will be a position somewhere. There we go. There we've got a section where there wasn't a response to be sent. So there will be times where there's a response that's not available because I'm only generating a response every 1.4 seconds, and at the moment I'm polling every 1 second. Now, just for a little bit of added information, I've brought back the slave sketch, which is still running on one of the other boards, and as you can see now, we can see not only the pings going through, but the responses that are coming back as well. Now, if you want to run this sketch on multiple boards at the same time, all you need to do is save it as a new version, change the ping number, because obviously every board needs a different ping address, and you can upload it to multiple boards and you will start to see all of the boards responding. Now, although all of this is working, and let's be honest, at the moment I am using a timer to generate some data. That could have been a button press or a sensor or something that's sending some information back. I'm now sending the ping from the master over to the slave. The slave is now sending some data back if it has some information, or not just sending it back to the master, but it's actually just transmitting that data. Now that we're working on the RS485 bus, any data that is transmitted from the slave is available for any other board to read. So don't think of it anymore as the slave responding to the master, as in the master gets all the data. It's just a case of the master is just controlling the timing of the system. Now, there is one more thing that we need to look at with the master. At the moment, the master is sending out pings, but as I said, it doesn't ping itself. So what happens if we want the master to be sending data as well as receiving a ping? So here we have version 3 of the master sketch. I've got version 2 on the right, just so that you can see the changes as we go down. Now, the important thing about this sketch is we want to be able to now send data as well as control the pings. Now, in the previous sketch, the main loop had the ping function, if you like, the code that controlled when pings were sent. Now what I've done is I've created a function called sendPing, and that is this function here, and this is sending out the ping information. Now, as we then look at the loop, the other bit that I've added in is a bit of test code, and it's a timer as usual, and this time it's going to send a fixed address of 111 and a fixed data of 112. Now, with the send ping function, one of the other things that I have changed is instead of it going, in my case, when the ping address got to greater than 4, sending it back to 1, I've created a variable called, where are we? Numping somewhere. That's it, number of boards to ping. And I've set this to 5. So this is going to work through 5 different boards, pinging their addresses one at a time. Now you want to keep this to the minimum number of boards that you have got. I've set this higher for testing reasons because I don't have to worry about it, but obviously the more boards that you have to ping, the longer it takes to get round all the boards. So if you've got sort of 4 boards, this is best set to 4, and 3 boards, 2 boards, whatever, but make sure you set this to the number of boards that you actually want pinging. Right, so we've done that bit of code there where are we? Where we're sending the ping. But also, as I've said, I've created a FIFO buffer, just as in the slave sketches, that is storing any data that needs to be sent. And now we have to get the timing of that sent data in the right place. So when I go to send the ping, so we wait until it's time to send the ping as normal, it then sets the transmit pin high, just as in the previous sketch. So let's have a look at the previous sketch's TX system. So we are sending the pin high, sending 5 bytes, flush, pin low. This one, I'm sending the pin high. Then, if there is anything in the FIFO buffer, it's going to transmit that packet. So if we go down to the TX packet, the big change that I have made is that instead of the digital write for the transmit pin being in the TX packet code, it's actually set back up here in the ping code. So what it's doing is it is sending the pin high, so it's saying I'm going to transmit, and if there is something in the FIFO buffer that needs transmitting, this is some data, it's going to send that information first. Now it's very important that the data, if you like, the non-ping is sent first, because don't forget we're going to respond to the ping. So as soon as the ping is sent, we need to release the transmit pin so that we can start receiving data. So we always send the data first, then we're going to transmit the same again. So I've called that TX packet function. I've sent out 5 bytes of data, but they are just data that I'm sending out. I'm then calling the function again, this time with my address 0 and my ping address that I am calling to. And after that, when I've done that, then once again flush the system and set the pin low, and obviously increment the ping address. And again, if I've got to the number of boards to ping, go back to 1. So it's using the same FIFO buffer system as the slave sketches are using. The only difference is that timing, and we're going to be sending 2 packets, one after the other. The first is the non-ping data, the second is the ping. Now, in this sketch, I am only sending out 1 data packet per ping. Now, this really depends on how your system is set up. So if your master has lots of information that it's sending out to the slaves, and the slaves don't really send much back, you may get to the point where you think, okay, I'm going to work through all the packets of data that are waiting in the FIFO buffer. So you might do a while loop there and just keep working through the FIFO buffer, sending out everything, and then send your ping packet. But in the way that I've got the system set up, it's pretty equal as to who is sending and who is receiving. Therefore, if I gave too much priority to the master, then there could be delays in getting some data back from the different slaves. So I'll get that one uploaded and you can see the results. Now I've uploaded the code, and at first it looks like it's working correctly. However, there is a problem. Let me just show you. I've reloaded Sketch 2, Master Sketch 2, and I want you to watch the data. I'm going to put the timers on. I'm going to stop the scrolling. And what have we got there? 1656.36. So 1656.36. We can see that the slave received a ping for board 1, and it responded with an address of 69, data value of 185, and a checksum of 254. If we look in the master, we can see that I have received that 69 and 185 as my address and my data. Now what I'm going to do is reload Sketch 3 again. So now I've reloaded master version 3, and I'm going to just stop the scrolling. And what I want you to notice is there is no received data. Now this sketch hasn't changed. The slave is still responding. I can actually see the data coming by. I can see the ping. I can see the random values that it sent back, but I am not receiving it in the master sketch. Now the reason for that is quite simple, but I'm going to show you why it's not being received, because this is something that is so easy to do in your code and wreck something through some minor error in your timing. So if we look at the version 2 and version 3 TX packet function, in version 2, the pin went high, I sent the data, I flushed the data, sent the pin low, and then I serial printed out what I just sent. With this one, we no longer send the pin high and low, because that is now done in our checksum, in the send ping. So the send ping now sends the pin high. It sends the first packet if there's data to be sent. It sends the second packet if there's data, which is the ping. So there's always going to be the ping. And then serial 1 flush, digital write the pin low. You would think it would work exactly the same, but there is a problem. Drove me mad when I first did this. I couldn't work out why I suddenly wasn't receiving the data, and the answer was, if we look again, the pin goes high, so it was going high here, flushing, going low. Then I was writing to the serial monitor the information about the packet. Now the pin goes high, I do all of this, and now it goes through the serial print before it then returns to my ping function. Now that means that this code that is being sent to the serial monitor is actually taking up a few milliseconds, and that those few milliseconds are taking so much time that the slave sketch has already started to try and transmit data before I've finished writing to the serial monitor. That is how tight the timing is. Now, if I just comment this out, everything goes away. Let's upload it. So now, obviously, I am seeing less data, but as you can see, I am now receiving every response to a ping that is coming through. And it's just something to be aware of, that with this sort of network protocols, just a simple serial print can be enough to upset the timing of your system. So to create what I have on the workbench, all I now needed to do was duplicate the slave sketch a number of times. So I created version A, B, C, and D. And of course, the real difference is the ping addresses are 1, 2, 3, and 4. That's to make, obviously, if I'd got two boards receiving the same ping address, they're both going to try and transmit their responses at the same time. That is not going to work well. So going back to the webcam, we'll just have a quick look at the sketch for this board, slave C. That's obviously got that blue, red, and green LED. The green LED only triggers when the button on the what's that, slave D gets pressed. So the slave C, it's got a blue LED on pin 5 using address 60. Pin 4 is red, 61, green, pin 3, 62, and that is seen in the process packet function. So if we look at the process packet, if it's case 0 for the address, then it's a ping, and we just check if it is a ping address for this board. And then if we have data to respond with, we respond appropriately. Otherwise, if it's 60, which is the blue LED, I do whatever the data says. So if it receives a 0, it will turn the LED off. If it gets a 1, it's going to write the pin high. And exactly the same happens for 61 and 62. Now going back to the workbench, one of the other ones that is odd here, all the other LEDs are triggered by timings. This one obviously is triggered by this button here, which is causing slave C to light or unlight the green LED. Now you'll notice on these sketches within the header, I actually wrote down the addresses and the board that it was on, and it's quite useful to either put them in the header of the sketch or even keep it all on a piece of paper or something, so you can keep track of what is doing what. One of the oddities with this one, it does have a debounce for the button, and all that happens is I then pin mode the button pin as an input, and within the main loop I am just using a very simple sort of debounce just to see has the state of the button changed or not. If the button state has changed, so button state is no longer the latest version of the button, then all it does is it sends that information to the FIFO buffer that address 62 needs to have an instruction, and that instruction will be the latest button state. So instead of using timing, it's using the button instead. Now, this button could have been a sensor, so it could be reading a temperature, all sorts of things, whatever your imagination, let it run wild. So I've used some buttons and timings to create the information to put in the FIFO buffer, but realistically you can do whatever you want. And instead of sending a 0 or 1, let's imagine at the other end of this we have a could be a servo, so I could send a value between 0 and 179 to set the position of a servo. So let's imagine that this is reading maybe a temperature sensor, and so as the temperature changes we could rotate the servo to give an indicator as to what the latest temperature is. So going back to the desktop, you can see now 5 Arduinos all sending communications between each other. Everything is being controlled timing wise by the master, but at the same time all the slaves are able to communicate to each other as well as to that master board. And the great thing about this is I've got 5 boards here, but we could be using up to 32 boards, and that distance between them, yes, I'm just stuck on a breadboard, but there's nothing to stop me having 1.2 kilometers of cable between each one. That is a very, very long distance. So I'm going to end the series on serial communication here. If you do have any questions, just email me off the Digital Town website or put something in the comments below the videos, and if necessary I will build another video to deal with the issues. I am going to do a project next using serial communication as part of the Model Railway series as a sort of a practical use of RS485 communication. So that'll be coming out hopefully in the next few days. So that's it for today's video. Again, with this beginners series, if there is any components that you particularly want covered, just let me know in the comments or email me off the Digital Town website and I'll see if I can include those in the series. So that's it for this video, and hope it's been useful. If it has, please help the channel by clicking the like and subscribe, and I'll see you in the next video. Bye for now.